Hello, ladies and gentlemen. Mr. Dorfler here with another daily dose of Dorfler. Actually, going to be one of your last daily doses for the semester. I know it's a real bummer for you, but we got to take a break at some point. So you won't see me until most likely at the end of the semester. The beginning of the year. I don't even know when I'm going to see you next. So who knows? Anyway, we're here with the last section of chapter 16. We're going to be looking at refraction of light, the bending of light, rainbows, different types of lenses, like if you have glasses like myself, just kind of looking at some interesting physics behind light, okay? So let's talk about light. Let's get through these notes. No math today, so should be pretty good. Go about normal pace, okay? Again, hit the pause button if you need to catch up on any notes. But anyway, when we have light waves, they are going to bend, or as we say, refract, when they pass from one transparent medium to another. That's because the speed of light is actually going to change when it passes through different mediums, and that's going to cause it to bend. So basically, if light is going to speed up or slow down as it goes between various transparent mediums, it's going to allow the light particles to travel faster or slower, depending on and that's going to cause its direction. So I'm going to show you here, as we see light passing at this angle here through a thicker liquid, we see that the light actually begins to bend or refract downwards at a much steeper angle than it originally was. Light waves that meet a boundary of two different mediums at an angle, the light is going to change direction, like we just saw in that example, okay? We tend to see light bend towards the normal. Again, that normal was that line that's right here. It kind of splits the two angles in half. And this is because the light moves from a material or medium in which its speed is high to a material or medium in which its speed is lower. So light moving through air and into water, as we saw in that example on the bottom right of the screen. When light waves bend away from the normal, this happens when light is going from a material that is slow speed to a material that is high speed. So we go from water to air. So we can get differences. We can get ones that are going to have much sharper angles or ones that are going to have much greater angles, depending on where it's traveling to and where it's going to. So if you've ever been standing over a pool or a river or any other body of water, like a pond or lake, we tend to see images a little different than what they would normally appear to be. Okay, it's because we have light that is being refracted through the water and the air. So it's going to appear as though some images or some objects are going to be slightly off kilter a little bit, if you will. Now, all of these images from refracted light will create what are called virtual images. We talked about virtual images a section or two ago. Now, if we look at an object in water from the surface, so much like if we were the cat, okay, and we are looking from air into water, what we would see is the light rays that pass from the surface into the water are going to be bent away from the normal. And so objects in the water will actually appear to be closer than they actually are. And so the fish itself is actually right here, but because of the light being refracted from the air to the water, it's going to appear as though the fish is right here, and the cat probably is going to have a difficult time in trying to catch that fish. Now, if we were the fish this time, if we were going from the water to the air, the light rays that pass from they're going to be bent towards the normal, okay? So the objects on the surface appear to be farther away than they actually are. This fishy thinks this kitty is basically way up here, but instead it's actually a little closer than what it may appear to be. So depending on whose perspective you are looking at, it's going to play a key role in determining how the light is being refracted. Mirages, you might see these phenomenon during the summertime, especially if you're driving down the roads in the middle of the summer. It's a virtual image that is caused by refraction of light in the atmosphere. The air temperature has an effect on light. As light from Earth's surface passes into a layer of hot air just above the Earth's surface, it refracts and bends upward away from the Earth's surface, and this causes a virtual image in the sky. So it almost appears as though the road is wavy. Sometimes people even mistake mirages for bodies of water. But that's all dependent on the air temperature and light's affected by air temperature. Lenses, again, if you have glasses or you may have other uses of lenses, the light passes through thin, flat mediums. They are going to be refracted twice. Once as it enters the medium and once as it re-enters the air. So two things are going to happen as the light ray passes through the thin, flat medium. The position of the light ray that exits the medium is going to be shifted, and the light ray is still parallel to the original light ray. Okay. Now, lenses are transparent objects that refract light waves in such a way that they converge or diverge to create an image. So if we have a converging lens up here, we tend to have light rays that converge. If we have divergent lenses, we have light rays that kind of move away from each other or diverge away from each other. When light passes through a medium that has a curved surface, the light rays are going to change direction. Light rays that pass through a lens has exiting rays that are not parallel to the original rays. So in converging and diverging lenses, each light ray strikes the lens at slightly different angles, causing the angles of the ray to be bent in different directions. For converging lenses, these bends the light waves inward, creates a virtual or real image. The type of image is dependent upon the distance the object is away from the lens. Divergent lenses bend light outward and only creates a virtual image. So as you see here, we've just barely started talking about lenses, and there's a lot of physics that go behind these lenses. A good friend of mine, she is a optometrist. I mean, she is considered a doctor because of the special training that they have to have. And I know that she had quite a few physics classes when she was going into become an optometrist, because you have to understand the varying types of lenses and how they converge or diverge light rays, depending on what each person needs. So there's a lot of thinking that goes into figuring out. I can't even talk today. It's Monday. Can you tell? When these I can't remember what I was talking about. I'm sorry. Anyway, diverging lenses, as I said, bend outward and they create only a virtual image. Okay, magnification. Now, this is something you're probably a little more familiar with, is the increase of an object's apparent size by using lenses or mirrors. Magnifying glass uses convergent lenses to enlarge the size of the object. This convergent lens of a magnifying glass creates a virtual image of the object being enlarged. There's a focal point on a magnification lens. A small area in which light rays converge together can be achieved in all magnification devices. You could really see where that focal point is if you have sunlight or a direct source of light and you move it in just a way that you can get that single point of light. There's all the light waves that are concentrated in that one point. Microscopes. You should have all probably used microscopes by this point in your science career. It uses multiple lenses to magnify an object. There's an objective lens, which is closest to the object. It forms a large real image of the object. Then there's the eyepiece. Okay, it acts as a magnifying glass, creates a larger virtual image of the object. So your object is going to be here on the stage, and here is your objective lens. It's just going to be right above that object you're looking at. And then here's your eyepiece. Again, all the way through here, there's body tubes. There's the various lenses that perform pretty complex forms of magnification. Light refraction and lenses in the eyes, okay? Light first enters the cornea. It's composed of transparent tissue, and it causes nearly 70% of refraction of the light in the eyes. Light then passes through the pupil and then through the lens. So here is going to be your cornea area. then it's going to pass through your pupil, and then it's going to pass through your lens right here. The lens in your eyes is composed of fibers. The curvature of the lens depends on how much the lens refracts light, and muscles can adjust the curvature of the lens until an image is focused on the retina. And that's kind of where sight issues can occur, is those muscles either aren't working appropriately or effectively. They could be strained. And so they're not having enough ability to adjust the curvature of that light, so then things appear blurry to you. Your retina is composed of light-sensitive rods and cones. The light strikes the rods and cones, which is going to send signals to the brain that are interpreted as images. Cones are in the center of the retina. They are responsible for color vision and only respond to bright light. Rods are on the outer edges of the retina, and they are sensitive to dim light. Does not resolve details well. It does allow you to see faint movements out of the corners of your eyes, so it gives that what's called peripheral vision. So now we get into dispersion and prisms. And so I'm sure we've seen prisms quite a few times in our lifetimes. In optics, it is a system that consists of two or more plane surfaces of a transparent solid at an angle with each other. A prism can separate the colors of light because the speeds of light waves traveling through the medium depend on the wavelengths of the light. And so the speeds of light through a medium might, it's going to depend on the wavelengths again. The longer the wavelength, the faster a light wave travels. So red light, it's the longest wavelength, and it travels the fastest. Violet is going to be the shortest wavelength of visible light. Therefore, it's going to travel the slowest. In dispersion, it is a process of separating waves such as white light of different frequencies into its individual component waves. Dispersion of light occurs between the wavelengths of visible light. It varies and bends at different angles. Sunlight passing through a prism. Sunlight is separated into all visible lights like a rainbow. All visible light travels at different speeds and bends differently as it passes through one medium to another. As we just saw, violet is going to be the slowest, red's going to be the fastest. Violet is going to bend more as it passes through one medium to another. The differences in speed and amount of light is because of causes the dispersion of light, as we see up here in the upper picture here. And lastly, the rainbow. Okay, rainbows are a pretty neat phenomena in nature. It's when we have sunlight striking a water droplet in Earth's atmosphere. Here we have light being dispersed in different colors and passes through water droplets. The light rays can be reflected in the water droplet at an angle of the refracted light is small enough. Light that emerges from water droplet is between angles of 40 and 42 degrees. If it's at an angle of 40 degrees, it's going to be violet. At 42 degrees, it's going to be red. And between those 40 and 42 degrees is the angle that all of the lights of possible spectrum, visible spectrum, emerges from the water droplet. And then light refracted through the water droplets is seen as arcs of color. Only red and violet light that refracted from water droplets reach our eye. All the other colors of the rainbow are separated in space. So that's kind of neat. Only the red and violet ones are what are reaching our eye. The other colors in between are just out there. So that is a pretty neat concept. Anyway, that's going to do it for Chapter 16. Again, if you have to pause the video at any time to catch up on the notes. I know I went kind of fast, but you know what? It's the last section of the notes, and there we have it. I will talk to each and every one of you next time. Make sure you do your homework that is going to be going along with this video as well. Have a great day.